Good morning, students. This is a computer class, and if you remember, if you recollect properly, okay, in the last class we had completed up to conversion from decimal to binary number. Okay, so today we are going to start with octal number system, okay, which is on page number 21. Okay, so this number system has 8 digits from 0 to 7. Okay, if you count from 0 to 7, there are 8 digits. Okay, with the base 8. Since there are 8 digits in this number system, you will have base as 8. Okay, this is also a positional value system where each octal digit has its own value expressed to the power of 8. Okay, this conversion of octal number system to decimal number system is similar to the conversion of binary number system to decimal number system. Okay, so if you look at the videos that I have sent you earlier, you can see the conversion of binary number system to decimal number system. So the conversion of octal number system is similar to conversion of binary number system to decimal number system. The only difference is the change of base. Okay, the base over here is 8. Okay, in binary number system the base was 2. Okay, so for an example, there is a number, okay, 2416. This is an octal number system. Okay, now you are going to change it into decimal number system. So how are they positioned? You have to look at this first. The digits are 2416. Okay, now for the position you will start with the left hand side. Now you will start with 0, since the octal number system starts with 0 to 7. So here you start with 0, 0, 1, 2, 3. Okay, the first 6 is the 0th number, 1 is the first number, 4 is the second, 2 is in third position. Okay, this is the position of the numbers. Now how will you convert it? Again you will start from the left hand side. Okay, now 6 into 8 to the power 0th position. Okay, now anything to the power 0 is always 1. Okay, this is the rule of mathematics. Okay, so 6 into 1 is equal to 6. Now 1, which is in the first position, 1 is equal into 8 to the power 1. So what is 8 to the power 1? 8. 8 into 1 is equal to 8. Okay, now 4 is in second position. So 4 into 8 to the power 2. Okay, so what is 8 to the power 2? 8 into 8, 8 2 times, okay, is equal to 64. Okay, now here you have got 4 into 8 to the power 2. So 64 into 4 will be equal to 256. Yeah, 8 to the power 2 is 64 into 4 is equal to 256. Now the last number, which is 2, is in third position. So 2 into 8 to the power 3, okay, is equal to, now what is 8 to the power 3? 8 3 times. 8 3 times is equal to 512. Okay, now 512 into 2. Why? Because the number is 2 over here. Okay, now when you multiply 502 with 2, you'll get 1024. So here's the number 1024, and lastly you will add up all these numbers. Okay, now the next number system is hexadecimal number system. Okay, this number system has 16 digits. Okay, 0 to 9, and after that you will represent it with A, B, C, D, E, F. Now already you have 0 to 9. Now from A you will count. A represents 10, B represents 11, C represents 12, D represents 13, E represents 14 and F represents 15. Okay, here it's written where A represents 10, B represents 11 and so on. Okay, this is also a positional number system where each hexadecimal digit has its own value expressed to the power of 16. Since there is 16 digits, okay, so the base will be 16 over here. Okay, as in octal number system there were 8 digits from 0 to 7, so the base was 8. Similarly here the base will be 16. Okay, the conversion of hexadecimal number system to decimal number system is similar to the conversion of binary number system to decimal number system. Okay, the only difference is the change of base. Again here the conversion is similar to binary number system to decimal number system, and the only difference over here is base. In binary number system is it is 2, over here it will be 16. Okay, for example the hexadecimal number given over here is 3b. So how will you convert it into decimal number system? First you will look at the position of the digit 3b. Again you will start with 0th, the first. B is in 0th position, 3 is in first position. Okay, now the number is 3b. you will start with the left hand side. B into 16 to the power 0. Why 0? Because it is in 0th position. Okay, now what is B? We have already learned that there are 0 to 9 numbers, and after that there are digits, alphabets which are represented as 10, 11, A is 10, B is 11 and so on till F. Okay, so B is 11. So B into 16 to the power 0 is equal to B is 11, and anything to the power 0 is 1. So 11 into 1 is equal to 11. Okay, now the other number is 3, or the other digit is 3 into 16 to the power 1, since it is in the first position. Okay, so 3 into 16 to the power 1 is 16, which will be equal to 48. Now you will add these numbers and get the answer. Okay, now computer arithmetic. You know addition, subtraction, multiplication and division of decimal numbers. Okay, you can perform the same operations on binary numbers too. Let us now learn binary addition, subtraction, multiplication and division. Okay, there are some rules for binary addition, subtraction, multiplication and division. So let us know the rules. Binary addition. Binary addition is similar to decimal addition. Okay, in binary, if the sum of two numbers exceeds 1, a carryover is generated. Okay, so there is a box given over here, and in the first column the rules have been given. So the rules are bit 1 and bit 2. Okay, there are additions of bit 1 and bit 2. Okay, and here you are getting the sum total. Okay, or the results of the addition of bit 1 and bit 2. 0 plus 0 is equal to 0, so there will be no carryover. Okay, 0 plus 1 will be equal to 1. Okay, no carryover again. 1 plus 0 is equal to 1. Again there will be no carryover, and 1 plus 1 will be 0, and there will be carryover of 1. Okay, So how this rule will apply? Here you can see in the example. Add 101 with 101. Okay, these are binary numbers. So 101 and 101 is added. Okay, so 1 plus 1 is equal to, here according to the rule, is 0. Okay, and there is a carryover of 1. Okay, 1 plus 0 will be 1. 1 plus 0 will be 1. Okay, again 1 plus 1 according to this rule is 0, and there will be a carryover of 1. So this one will simply come down over here. So the answer will be 1010. Now the binary subtraction. Okay, binary subtraction is also similar to subtraction of decimal numbers. Okay, you need to borrow from next higher bit in order to subtract a higher bit from a lower bit. Okay, so there are rules over here and there is an example given over here. So first we'll look at the rules. Okay, so bit 1 minus bit 2, okay, which is 0 minus 0 is equal to, what will be the result? 0. So no borrowing. 0 minus 1 is equal to 1. Borrow from left. Since there is 0 over here, you are going to borrow from the left hand side. Okay, so 1 minus 1 according to the rule of binary subtraction will be 1. Again 1 minus 0 will be equal to 1. No borrowing. Okay, 1 minus 1 will be equal to 0. Again no borrowing. Okay, so how this rule will be applied in the practical manner, we will look at it over here. Subtract 11 from 101. You are subtracting 11 or 1 from 101. Okay, so the numbers given over here are 101 minus 1 1. 1 minus 1 will be 0. 0 minus 1. Okay, so you cannot subtract 1 from 0. You are borrowing, okay, 1 from over here. So 1 minus 1 according to the rule given over here, 1 minus 1 will be equal to 0. Sorry, okay, the thing over here is 0 minus 1 according to the rule is 1, but since the number above here is 0, you will be borrowing from here. Okay, so the borrowed number but over here will not be relevant. Okay, so since you have borrowed 1 over here, you will have 0 over here. So this 0 will come down over here. So the answer ultimately will be 0 1 0. Okay, now binary multiplication. Binary multiplication is similar to the multiplication of decimal numbers. Here are the rules. 0 into 0 will be 0, 0 into 1 will be 0, 1 into 0 will be 0, 1 into 1 will be 1. Okay, there is not much confusion in binary multiplication. So if you multiply 1001 with 1 1, what will be the result? We'll look at here. 1 into 1 will be 1, 1 into 0 will be 0, sorry, 1 into 0 will be 0, 1 into 0 again will be 0, 1 into 1 will be 1. Okay, here there will be 1, or you can put an asterisk, there will be 0 over here, or you can put an asterisk over here. 1 into 1 1, 1 into 0 0, 1 into 0 again 0, 1 into 1 will be 1. So finally you will add up the numbers and get this answer. Now how binary division works. Binary division is similar to the division of decimal numbers. So if you divide 1001 by 10, what will be the answer? We'll look at it and how the process works in binary division. Okay, so 1001 is divided by 10. So 10 into 1 will be 10. If you subtract it, you will get 1 over here, again 0 over here, again 10 into 1 will be 10. Okay, so 1 minus 1 is 0, 0 minus 0 is 0, and the other one comes over here. So this will be the remainder, this is the dividend, and the quotient is 110. Okay, so we have completed the chapter. Okay, and lastly we'll know some facts. India invented the number system. Okay, so the number system was first invented by India. Okay, 0 was invented by Aryabhatta. Okay, you must have all heard about him at some instance. Okay, at some point in mathematics or some other subject. Okay, Aryabhatta was the one who invented the number 0. The place value system and the decimal system were developed in India. Okay, also the place value system, okay, and the decimal system were also developed in India. So key points from the chapter. Number system is a set of values used to represent different quantities. Okay, decimal number system has 10 digits, 0 to 9. So the base will be 10 over here. Binary number system has 2 digits, which is 0 and 1. Okay, so the base will be 2 in binary number system. Octal number system has 8 digits. Okay, 0 to 7. So the base in octal number system will be 8. Hexadecimal number system has 16 digits, 0 to 9, and the rest will be represented by the alphabets from A to F. So the base will be 16 for hexadecimal number system. Okay.